Today we're going to go over Lesson 8.2, Day 2 on multiplying and dividing rational expressions. So first let's go over some vocab. A rational expression is a quotient or fraction of two polynomials. Then we have excluded values, which are values of x that make the denominator equal to 0. We're going to find these excluded values after factoring, but before we simplify. So let's go over a few examples where we need to simplify and identify any x values for which the expression is undefined. So starting, let's take a look at number 1. There's nothing that we can really factor out right now, but we can take a look at our excluded values. So what I'm going to do is look at that denominator, and I'm going to write that off to the side and set it equal to 0. Okay, so now we're just solving for x. So I'm going to divide by 6 on both sides. So that gives us x to the 4th equals 0. So now we're asking ourselves, what to the 4th power would equal 0? And that answer is 0. You can also type in the 4th root. We've done that earlier this year in Algebra 2, so you can type 4th root of 0 into your calculator as well. So remember, this is our excluded value, so this is what they are telling us that x cannot equal. So make sure you draw a slash through that equal sign so we know this is what x cannot equal, because it would make the denominator 0. Okay, next up we are going to simplify our fraction. So take a look back over here. We've got a 10 in the numerator and a 6 in the denominator. We could divide both of those by 2. You can also use your ABC key to help you simplify there. So that would reduce to 5/3. And then we need to divide x to the 8th by x to the 4th. Now remember, when we are dividing exponents, we subtract them. So we go where the bigger one is, which is 8 on the top, and we take 8 minus 4. So that gives us x to the 4th on the top. So our final answer is 5x to the 4th divided by 3, where x cannot equal 0. Okay, let's take a look at number 2. So starting off, I can see that I can factor the denominator, so I'm going to go ahead and do that right away. The GCF in the denominator would be 8. So I have 8 times x squared plus 1. So I just divided both of those terms in the denominator by 8. So now that I have factored, I can figure out what my excluded values are. So I'm taking that denominator, just write it off to the side somewhere, and I'm setting it equal to 0. So to start, I'm going to divide both sides by 8. So those 8's cancel out. We get x squared plus 1 equals 0. So really, we're only going to end up working with the parts of the denominator that have a variable in them. So now we can subtract 1. We get x squared equals -1. Then we can take the square root of both sides. So x equals plus or minus the square root of -1, which is I. So that is what x cannot equal. So really what we're saying here is that x is going to be an element of the real numbers. We know it's not going to be imaginary. Okay, so let's take a look back over here. We can now continue simplifying. We've got a 16 in the numerator divided by an 8 in the denominator. 16 divided by 8 is 2. So we're left with a 2 on the top. This is really a 1. So 2x to the 3rd. And then on the bottom, you can just distribute in that 1. So it's just x squared plus 1. So our final answer is 2x to the third divided by x squared plus 1, where x is not an imaginary number, x is in the real numbers. All right, now let's take a look at number 3. So with number 3, I can see that I can factor the denominator. I'm going to factor it into 2 binomials. You can do the AC method, or you can just guess and check. Remember, we're working with factors of C that add up to our B term. So the factors of 4 would be 1 and 4, 2 and 2. And I'll let you work on the factoring. If you want to pause and try it on your own, you can do that and then check your answer. You should end up with 4 and 1, and then our 4 is going to be positive, the 1 will be negative. So you can see that that gives us 4x minus 3x, which would be 1x, our middle term. Okay, now that we have factored the denominator, we can find our excluded values. So I'm going to write off to the side 3x plus 4 times x minus 1 equals 0. And with the zero product property, we can set both parts, or both sets of parentheses, equal to 0. So I have 3x plus 4 equals 0, x minus 1 equals 0. And we're going to solve for x in both of these equations. So here I can subtract 4. We get 3x equals negative 4. Then we can divide both sides by 3. So that tells us that x cannot equal negative 4/3. Then if we go to the other equation, add 1 to both sides, that tells us that x cannot equal 1. So those are our 2 excluded values. Sometimes you're only going to have 1, and sometimes you might have multiple, sometimes you might not have any. So just make sure you're always checking that denominator. All right, now let's go back over to number 3 and see if we can simplify. I can see that I have 3x plus 4 on the top and the bottom of my fraction. So those will cancel out and leave us with 1s. So we have 1 on the top, and then on the bottom, distribute in that 1. So we just have x minus 1. So our final answer is 1 over x minus 1, where x cannot equal negative 4/3 or positive 1. Next, we're going to talk about multiplying rational expressions. So we're going to factor if possible and simplify. So our directions for number 4 and 5 are to multiply and assume that all expressions are defined. So whenever you see this statement in your directions, assume that all expressions are defined, you don't have to worry about saying what x cannot equal to, like we did in the last problems. So number 4, so some people like to multiply right away, and some people like to simplify first. So it's totally up to you. If you simplify first, you're going to be working with smaller numbers and smaller exponents. But if you prefer to multiply it first and then simplify, that is fine as well. You should get the same answer. So I'm going to simplify first. So I see that I have a 3 in the numerator and a 9 in the denominator. So I can simplify that to 1 and 3. So I'm just dividing both of those by 3. Then I can see I have a 10 in the numerator and a 2 in the denominator. So if I divide both of those by 2, we get a 5 and a 1. Now we can take a look at our variables. Remember, when we're dividing or we have a fraction with exponents, we subtract them. And some might just cancel out. Like I can see here, I have x to the third and then x to the third in the bottom as well. So those can just cancel out. We also have, let's see, we've got y to the third and y to the fourth. So that would be y to the seventh on the top. And we have a y to the seventh on the bottom. So these two can cancel out with this one. Okay. Now we have x to the fifth on the top and x to the second on the bottom. So we can subtract 5 minus 2. So that would give us 3 x to the third on the top, and this one would be gone. And that is everything I can simplify. And you could have done it in a different order too. There's not only one order of simplifying. That's just what I did. So hopefully you can figure out what works best for you. So now that we've done that, I'm going to multiply. I'm going to make sure it's clear here that that one's x to the third. So first I'm just going to multiply my coefficients. So I have 1 times 5, which is 5. And then I also have x to the third on the top. And that's everything in my numerator. Then on the bottom, we've got 1 times 3, which is 3. And then we have y to the fifth. And that is everything in the denominator. So our final answer, if we can't simplify it any further, is 5x to the third over 3y to the fifth. Alright, let's give number 5 a try. This problem is going to be a little bit different. We're going to do some factoring first. So I'm going to start with the numerator of my first fraction, and I've got that negative in front, so I'm going to factor that out. So that would give us a negative 1 in front times x minus 3. Then in the denominator of that fraction, my GCF is a 4, so I'm going to factor out a 4. So we have 4 times x plus 5. Now in my second fraction, the numerator, I can't simplify or factor it all right now, so I'm going to leave that. And then the denominator, x squared minus 9, that is a difference of perfect squares. So we can factor that into two binomials. Take the square root of the first term, the square root of the last term, and then we have 1 plus 1 minus. Now that we have factored, you can see that we can start canceling some things out. So we've got x minus 3 in the top and the bottom, so those can cancel. And then we've also got x plus 5 in both the numerator and denominator, so those cancel as well. So now we can multiply our fractions. We've got a negative 1 on the top, and then on the bottom we have 4 times x plus 3. Now if you want to distribute that so you get 4x plus 12, that is fine. If you want to leave the 4 in front and write 4 times x plus 3, that would be fine as well. So either of these answers would work for number 5.